Hi everyone, I'm happy to connect with you all through another informative video. In this video, we are going to learn the definition of cloud computing. That seems to be funny, right? Because we are well aware of cloud computing today, and we are well known to the definition of the cloud computing as well. But what I've planned for today's video is to ensure that we apply the definition in a reality. So meaning is, I'm trying to demonstrate the definition of the cloud computing by taking the AWS environment as an instance, and with that we will get to know the better understanding on the definition of the cloud computing. So firstly, let's look at the definition that's been officially defined by an organization called NIST. So what they say here is, cloud computing is a model for enabling ubiquitous meaning is everywhere, right? So ubiquitous, convenient and on-demand network access to a shared pool of configurable computing resources. The computing resources examples are networks, servers, storage. Storage could be in hardware storage, or it could be a database storage, applications, and even services. So all these are going to be considered as an IT resource, and they give it in a more generic term called computing resources, but technically we can even call it as an IT resources. So the IT resources are going to be accessed through the network, and we define that as an internet. So via the internet, we will be able to access a pool of network, a pool of service, a pool of applications or services that's going to be offered by a cloud provider. So cloud computing is considered to be a model. By itself, it's not a technology. Cloud computing is not a technology, it's just a model which has some set of rules and standards which we need to follow in order to ensure that we are on top of the cloud computing. So these resources like networks, servers, storage, applications and services can all be rapidly provisioned. So what do we mean by rapidly provisioned is, we need to spin up an Linux server, right? I just wanted to launch my web applications on top of an Linux server. Then I can just go to the cloud computing provider and ask them to provide me an Linux server where I'm going to launch my web application. So spinning up that server is going to be quite easier, and as well as it's going to be instant. So that's why they say it's more convenient, right? Instantly we can provision a server, and we can deploy our application into the server, and we are ready to access that application in a minute of time. So basically, if you look at this definition, what it says is, it's all about a model. Cloud computing is just a model which is composed of 5 essential characteristics. Okay, so what are those 5 essential characteristics? We will have a look at it shortly. And there are 3 service models which we have, and also we have 4 deployment models. So what are those 5 essential characteristics? The 5 essential characteristics are on-demand self-service. Okay, so when we talk about the cloud computing, the characteristics of a cloud computing is on-demand self-service. So meaning is, we can provision a server by ourselves. So let's take an example of AWS, or let's take an example of Azure, where you can go to the cloud providers and you can make use of their tools in order to launch a particular Linux server or Windows server by yourself. So it's a self-service on demand. So on demand is when you need, you can go and prompt for a particular service from the cloud provider, and they will be eligible to offer you those services whenever you need. So that's what it means, on demand and self-service. So I don't need to rely on any specific IT technician to help me out in spinning up a server by putting them into a server rack and ensuring installing an operating system for it and helping me all the way to ensure that the server is up and running. That steps are not required, because it's more of an on-demand self-service. Yes, of course we need an IT technical guy who's going to be involved in order to enable this services much faster, but not in a physical manner, but it's going to be on a virtual manner. So on demand self-service. So we don't need to rely on the cloud providers as well, because they provide a tool. We are going to make use of the tool to ensure that we consume their services whenever needed, and it's going to be consumed and it's going to be created by ourselves itself. So that's why it's called as in self-service. So on-demand self-service, and the second is broad network access. So what do we mean by broad network access when it comes to the cloud computing is we need to ensure that the access of those services can be done via any resource constrained devices. It could be a desktop, it could be a laptop, it could be a mobile phone. So from anywhere we'll be able to gain an access to the cloud computing services. So it should be broad network access. It's not just constrained to a specific network. You'll be able to have the access to those services. So it's a broader network access. So you will not find any challenges in accessing those resources, and you should not find any hindrance in accessing the resources that's going to be offered by the cloud provider. The third characteristics is all about the resource pooling. We are well aware of this term called resource pooling nowadays, because we do a carpooling, we do a bike pooling, and so on. So it's more similar to that. So the resources which are going to be offered by the cloud provider are going to be shared across many peoples, and we don't know where that resource is going to exist. So I might be located in one geographical location, but the service might be located in somewhere else, and that service can be accessed by multiple people, and that's called as a multi-tenant services. So multi-tenant services is like considering that we are in an apartment where we have some 5 apartments, and that 5 apartments are taken by 5 different individuals, right? So it's going to be shared. That space is going to be shared across multiple people. The same way here, the computing resources or IT resources are going to be shared across multiple organizations or multiple people. So it's going to be resource pooling. So you're going to pay only for what you're going to consume, right? So that's why we call it as a pay for what you consume, or pay for only what you use. So the resource pooling is one of the added advantage in terms of cloud computing when it comes to its characteristics. The fourth is all about the rapid elasticity. So rapid elasticity is like you wanted to grow your capacity suddenly. Yes, of course. So you can scale in and scale out. So whenever needed, you can scale in. Means I just wanted to increase my storage. So let's say right now I'm consuming with 20 GB of my storage, and suddenly I just wanted to increase to 30 GB. So can I increase that storage? Yes, of course. So that's why it's called as a rapid elasticity. So if you want to enhance your network services, of course you can do it. So meaning is whenever needed you can scale in, and whenever needed you can scale out. So if you want to reduce your resources, suddenly you are not going to consume anymore, then probably you can scale out your consumption of resources. The fifth characteristics is all about measured service. So what do we mean by measured service? Is like what we consume can be monitored, right? So it will be a metered access, like how we are using electricity at our home, right? So you have the option to monitor how much electricity that you're consuming, right? So you have a meter provisioned at your home, and every day or probably 15 days once you can just go to the meter and watch out for the consumption of your electricity, right? Similarly, in the cloud computing service provider environment, they'll be providing you features where you'll be having an option to monitor and gain the informations about the consumption of the services that you do from that particular cloud service provider. So when cloud service provider is saying that they are implementing a cloud computing environment in them, then they need to follow all these 5 characteristics: on-demand self-service, broad network access, meaning is the services should be accessible from anywhere and everywhere without any constraints on it. And they should also offer a resource pooling, so where their resources can be shared across multiple organizations, and there should be a rapid elasticity, so they should offer you an option to scale in and scale out your consumption of resources, and also they should offer monitoring services for the consumption that you do. So it's called as a measured services. So these are the 5 essential characteristics that a cloud computing should hold. So the next thing is the cloud service models. So from the cloud computing definition point of view, we are talking about the characteristics of the cloud, and now we are going to look at the service models that the cloud should provide, or the cloud provider should offer. So cloud computing service models are software as a service. So if a particular cloud provider is going to offer their softwares on top of the internet, then it's going to be called as a software as a service, right? So that cloud provider might offer only the software as a service in them. Another cloud provider might provide a platform as a service as well, right? They will offer you a platform but not the software. So it's your intention to go and deploy your own softwares on top of the platform that they are going to offer. The third one is infrastructure as a service. It's not just about the platform. To ensure that the platform is up and running, we need a complete IT infrastructure, which includes your physical locations where you need to place your server, and you need to have the specific equipments to deploy those physical servers. And on top of the server only we'll be having the runtime platforms, and on top of the runtime platforms we will be provisioning our software. So this service model will have a more detailed video on this particular topic at a later point. But right now, just to quickly conclude that the cloud computing service models are segregated into 3 basic terms. One is SaaS, which we call it as software as a service, and PaaS, which we call it as a platform as a service. The third one is IaaS, which is infrastructure as a service. So there are cloud providers who offers all these options like software as a service, platform as a service, and infrastructure as a service. But there are cloud providers who offer only software as a service, right? So, or there are providers who offer only platform as a service. So we'll have more discussion on that at a later point of time. But right now, just understand that service models are of 3: software as a service, platform as a service, and infrastructure as a service, which you might be aware of it. But I just wanted to reiterate on this term because this is an essential information that is part of a cloud computing definition. The next one is a cloud deployment model. So what is this deployment model? You might be aware of, or the people you might be new to this term. So this deployment model means we are going to ensure that the cloud computing is going to be deployed in a public aspect, meaning is it's a public cloud, so anyone can access that the cloud environment, right? So the deployment model, the cloud computing deployment model, is of a public cloud. And by now you knew what is the second one is, the private cloud, yes, of course. And the third one is hybrid cloud, and the fourth one is community cloud. So public cloud, private cloud, hybrid cloud, and community cloud. So cloud computing deployment models are segregated into 4 aspects. The public cloud is a place where anyone can access the services, and that service can be shared by multiple people, right? Let's say, for example, I'm going to consume an database service, and the storage for the database service is going to be accessed on top of the public cloud deployment model. Meaning is there might be 3 or 4 people who might be accessing the same database service and their storage. So my data and the other person's data will all go to the same database storage space itself. So the meaning is that particular service is accessed by public, so that anyone can access that service and make use of it, and it's going to be shared, and you're going to pay only for what you're going to consume. Private cloud is exclusively for a single entity. So I'm going to own that particular service, and it's only for me, and that space which is allocated for me, let's say for example I'm consuming 20 GB for the database service that I'm going to use, then probably that 20 GB, whether I'm going to use the entire 20 GB or I'm going to consume only 2 GB out of it, that entire space is only for me, and no one is going to share that, and no one is going to occupy the service which I have consumed. So that's exclusively for the private access. So it's an independent organization who's going to make use of that service, and that's not going to be shared across multiple other organizations. So public cloud, private cloud, and the second one is hybrid cloud. Hybrid cloud is a place where we will make use of the public and the private cloud combined together, right? And we also have a community cloud, and that's something which is not predominantly used in the market today. But of course, we land up with public, private, and hybrid cloud as a variant of deployment models. But we do have a community cloud, where the community cloud means, as the term states, it's for the entire community, right? So let's say, for example, it's more relevant to the private, but you might be having more people involved into that particular private access that's called as a community. So let's say, for example, I have an organization called X, Y, and Z, and all these three organizations are going to be clubbed together as a community, and all these three organizations alone can access the services that are going to be offered by the cloud. So that's what we mean as a community by itself. So public cloud, private cloud, and hybrid cloud are the predominantly used variants of cloud computing deployment models today. And we do have the fourth one, community model, which is sparingly used today, but still it is in existence as well, right? Okay, so to summarize, what we have learned is the basic definition of cloud computing, and we saw more specifically the deployment models, right? And there are ways where we can have more different definitions for this cloud computing. But this is something which is officially defined by the organization called NIST. So we'll just quickly go ahead and see this NIST, which is National Institute of Standards and Technology. Okay, so this NIST is an organization which actually does the job of creating a standards for an innovative technology that comes up. So they are exclusively for creating a standardizations for the specific technology. So they have given a lot of descriptions and definitions, more neat explanations for the term called cloud computing. The NIST definition of cloud computing is well acceptable from different cloud vendors as well. So this is a PDF document, and the link will be offered in the description of this video. So you can just go through on this PDF to have more technical understanding of what the cloud computing means. So I have taken the information from this particular documentation offered by the NIST. So, but apart from that, there is a definition which is given by AWS itself. So AWS is Amazon Web Service, and they offer the cloud services, and they are a cloud provider, right? So cloud providers are the one who offers the services on internet. The services could be a network service, a storage service, or it could be a database service like application services. So, but these services are going to be offered on top of the internet, and that's why we call it as a cloud services. And AWS is one of the cloud provider who are leading in the market today, and they have given a specific definition what is cloud computing. More or less, it's going to be similar to what we have learned from the NIST way of definition. So cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing, right? So they say that the entire IT resource, what NIST says is computing resources. So if you look at the definition of the NIST, they say it as a computing resources, okay, configurable. It's more configurable as well. The resources can be configured by us, so that's why it's more convenient. So computing resources, right, like network, server, storage, or applications. But what AWS says is IT resources. So cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access the technology services such as computing power, which could be the entire computing power and the storage for the computing and the database as well, on an as needed basis from a cloud provider like Amazon Web Service. And that's what we call it as an on-demand. So whenever need, you just go and consume that services. Okay, so let's move on to Microsoft and see what Microsoft is having in its kitty for the cloud computing definition. So if you look at this, it says cloud computing is the delivery of computing services including servers, storage, databases, networking, software, which we call it as applications, analytics and intelligence is all there available on the internet. You just go and consume what you wanted, and you consume only the time that you need it. So once you figure out that you don't require that service anymore, then you can disconnect the consumption of that service. So with that, you're going to pay only for what you're going to consume. So over the internet, and again I'm saying it's over the internet. All these services are available over the internet, and that's the final conclusion for understanding the term called cloud computing. So any computing services which are offered on the internet is going to be a part of the cloud computing, but it has to follow certain standards which are already defined under the term called cloud computing. So this definition also seems to be more similar to what we have seen from AWS point of view, and as well as from the NIST point of view. And finally, we'll end up from the Google cloud platform, which we call it as a GCP. So Google is also one of the cloud provider, and Microsoft is also one of the cloud provider, and they offer through a brand name called Azure, which you might be aware of. So AWS, Azure, and GCP are the three major players on the cloud computing world, and the leading is AWS, which you might be aware of. So what Google says is, understanding the types of cloud computing resources can be time consuming and costly. So enterprise need to buy physical servers and other infrastructure through procurement process that can take months and support the architecture of cloud computing. So the acquired system require a physical space, typically a specialized room with sufficient power and cooling, which we need to maintain that particular service. After configuring and deploying the system, enterprises needs to expert personnel to manage them as well. So instead of doing all these physical activities today, we are moving. All major organizations have done a major shift by moving from their data center, their entire infrastructure implementations as well moved on to the cloud premise, right? So we call it as an on-premise and cloud premise. So on-premise is place where we, as an organization, we maintain the entire IT setup, but now it's going to be shifted to the cloud. So Google is also coming up with a similar definition. So why we need to go and spend time on that, money on that? Instead, we offer the service. You consume only what you want. If you want to park your application, you just come and park the application on the cloud environment. If you want to park your entire network, you just come and park your network onto the cloud environment, which we offer. So it's as simple as that today. But yes, of course, we still need the expertise on the cloud. So only the cloud expertise can help us in coming up with a better solution to deploy the entire organization's IT setup on top of the cloud environment. Okay, so these are all the theories. I knew that I've covered up a lot of theory, and we have understood the basics of what cloud computing is all about. But let's quickly go on and see how that on-demand consumption of services can be achieved. So we have seen the characteristics of the cloud computing, right? So those characteristics can be looked at from the point of real-time implementations. So I'm considering the AWS as one of the cloud provider. So I've considered the AWS as an example for this video. So I'm just going to quickly go to the aws.amazon.com/console, and I'm not going to teach you anything on the creation of the account or how to access on it. It's just a demonstration for the understanding of the definition that we have gained, right? So on-demand self-service, the first thing that we are going to look at is on-demand self-service. So on-demand self-service can be done by this way. So I'm just going to sign up onto the AWS environment. With that, we'll be able to quickly spin up a specific server that we needed. So just feed in your credentials. So right away, we are going to see how we are going to utilize the on-demand self-service characteristics can be accomplished with the help of this AWS provider. So I'm going to offer my multi-factor authentication code, and we go. We have successfully logged in to the console of the AWS. So this is the AWS console screen, and here you can see that there's a services option. So if you look at it, analytics, application integrations, AR and VR, computing services, container services, database services, development tools as a services, right? So these are all the different types of services which are offered by AWS. So anyways, we are going to see more in detail about the services, the three types of services, service models that the cloud offers, that is a platform as a service, infrastructure as a service, right? So the thing is, coming on top of the AWS offers hundreds of services, but whether those services are part of platform as a service, or is that going to be an infrastructure as a service, or is that going to be a software as a service, that depends on the type of service that you're going to consume. So here I'm going to quickly launch a particular Linux instance, and we are going to access that Linux instance. So in order to do that, AWS is offering an EC2 services. So it is called as Elastic Computing Services. So we are going to move on to that service. So as you can see right now, I don't have any instances running. So we are going to quickly look at creation of an instance. So here we have the option to launch an instance. So it's a self-service. I'm myself performing the steps to spin up one Linux server and ensure that the Linux server is used for different purpose, like deploying our application into it and access the application from anywhere, right? So just quickly give the configuration details. So I'm going to give it as my web server, and go ahead and choose the type of Linux instance or Windows instance that you wanted. So here it's Amazon Linux is there, Mac operating system is there, which is accessible on the internet, right? Ubuntu or Windows or Red Hat. It depends on which, it depends on your requirement. You have to go and choose the type of instance that you wanted. So right now I'm going to make use of the free tier eligibility instance alone, okay? Because other than the free tier, anything which I'm going to consume, I need to pay for it for the number of hours that I'm going to consume that instance. So to be on the safer side, I'm just picking up on the free tier eligible one, and the instance type is explained here, and as well we need to generate a key pair to access that instance from an external applications. Means we will be SSHing the instance. So at that time we need the key pair to be associated for it, and already I've created a key pair, so I've chosen the one which I've already created, and I've downloaded the key pair version onto my local machine as well. So then rest is all pretty network related one, and also we'll be having a storage related one. So we have 8 GB of hard disk capacity which we are consuming it, which is called as Elastic Block Storage, EBS is what we are consuming it. EBS is one of the services that's offered by AWS. So I'm choosing 8 GB of my hard disk. Typically to say it's just a hard disk, but it's a shareable hard disk. So, and also you should notice that the Linux instance which I have chosen here is going to be of 1 GB of RAM, right? So 1 GB of random access memory is what is offered from the T2.micro version of instance. And by giving all these informations, feeding in those informations, and that's it, I guess, we can just go ahead and launch the instance quickly. And this will take some few seconds to launch the instance, and from there we can ensure our instance is up and running. So right now, if I go back to the instances screen, you can notice that the instance of my web server, which is a Linux version of instance, and the status is pending. So if I just refresh, keep refreshing, and to notice that the instance is coming to the started state, so that we will be able to have an access to that particular instance. So right now you can notice that the instance is up and running. So just click on this instance ID, and by that way you will be having an option to connect to the instance. So there are two ways to connect to the instance. So one is You can connect it through SSH, or you can connect it from your from the browser itself. So right now I'm going to explain you on how to connect this this newly created instance, which is up and running, which is a Linux instance, through the SSH option. So what I'm going to do right now is I'm going to launch my iTerminal on my Mac, and I'm going to copy this this example which they have offered here, right? So this, you can copy it. This is the PEM file which we need in order to access this instance, because this PEM file is the one which is associated to the credential. So we need, in order to access it through the SSH environment, we need this PEM file, so which is already downloaded. So I'm going to see that I'm into the downloads, and there you'll be finding something called the PEM file. Okay, so here you can notice that summary-demo.pem file is already there in this directory, and from here we are going to use the command that we have copied. So just copy this and place it here, and also to ensure, I'm just removing that double quotes which is given for the PEM file. So SSH-I interactive. Okay, interactively you connect to this instance, and it's an EC2 instance which is connected, and I'm going to connect it as an EC2-user, as in a user, to log into the instance. Just enter, and can't be established. Okay, so this is giving an error. So this key is not known by another username. So just saying yes. Okay, so this error is initially relevant to the authentication of that particular PEM file, but still, if we just go ahead and give S, it connects to the Linux system. As you can notice that we have been connected to the Amazon Linux machine. So right now you can see that it is connected as an EC2-user, and you're all done with this. So you can just go and do whatever you wanted from here. So it's like connecting to the Linux environment, and you're going to use all the Linux commands to feed in to access that Linux operating system. So this seems to be pretty simple, right? But the actual understanding is we are learning this from the point of on-demand self-service. So I myself created an EC2 instance which contains a Linux system in it, and I needed at this point of time, so I picked up one instance. So it's more of an on-demand self-service. It's not only limited to the computing systems, but also it's applicable for network storage or database access as well, right? So broad network access. So this AWS provider service can be accessed from any devices from anywhere. So there is no specific constraint on that. So it is having a better access. So that's what NIST says. So you have an access to that application or the platform, either from the mobile phones or tablets or laptops, or even from workstations. You will have an access to those services. Resource pooling. Yes, of course, it's a resource pooling because I don't own that service anymore. It's been a shared resource. So I'm utilizing the 8 GB of hard disk from let's say it's more of 1 TB of hard disk. From that 1 TB of hard disk, I'm consuming 8 GB. Another person is going to consume 8 GB on the same 1 TB of hard disk. So it's more of a resource pooling. And rapid elasticity. Yes, of course, if in case you want to increase your capacity sorry, of the EBS, of course you can go ahead and increase the storage capacity as well. So you have the EBS storage volumes. So right now you can see it's only 8 GB. If you want to add one more 8 GB of EBS storage, you can just, or whatever amount of storage that you wanted, you can mention that and you can create it. So it's more of elastic, meaning is whenever needed, you can scale in and scale out your services. So it's more of rapid elasticity as one of the characteristics that's been supported by AWS because it calls itself as a cloud computing platform, meaning is it has to follow all these principles and characteristics as well. So measured services, yes, of course, you have the option to go and see how much consumption of storage you have done. And for all these, you will be having the option to go to your account sections, and from there you will be having multiple features which are enabled to know the consumption of your services. So let's say, for example, I go for the free tier and notice that what I have consumed on the Elastic Compute Cloud. So how much EBS storage that I've consumed, what is my current usage. So all these are monitoring services, monitoring features on top of the service that you have consumed, and that can be pretty much helpful in order to ensure that you are not crossing your consumption limit. So measured services is something that where you will have an option to monitor your services. So you have a metering services which will help you to keep constantly keep monitoring on the consumption of your services. So this is what the 5 characteristics that we call under the cloud computing terms. And if you notice that the AWS is efficiently implementing all the 5 essential characteristics. These are the mandate characteristics, but there might be multiple other characteristics that the cloud computing might have, which might be offered by the different service providers like AWS or GCP, the Google Cloud Platform, or could be in Microsoft Azure. So I hope we got a basic understanding of what the cloud computing is, and what are the characteristics of cloud computing, and what are the service models like platform as a service, infrastructure as a service, and software as a service. And also we have seen the cloud computing deployment models like public cloud, private cloud, hybrid cloud, and community cloud. But we have a more interesting study on the deployment models as a separate video, and also we will have a separate video on the service models like platform as a service, infrastructure as a service, and software as a service. So that will be lined up in the upcoming videos. So with this, I end up this video, and if in case you have any queries, please post it on the comments. I'm happy to respond to your queries as well. So thank you so much for your time, and have a great day.